Okay, I like this part of the unit. It's just drawing graphs. It's not actually finding first and second derivatives, but understanding what they say about each other's graphs. Okay, so this to me is really actually kind of fun. I would suggest you have at least 3 colors. So I'm going to be working with 3 colors here. In my notebook, I had a blue pen, a black pen, and a pencil. So something like that, so that you can put them all on one graph. That would make it a lot easier than making 3 separate graphs of them. All right, so what I've done is I've already got the original function graphed. Okay, you can see it's a parabola. So now my job is to go ahead and sketch the graph of the first derivative and the second derivative. So that's what I'm going to do now. All right, so what does the first derivative say well, the first derivative is talking about the slopes, right? So what is the slope of this point right here on the original graph that's the minimum? Well, because it's a minimum or a maximum, the first derivative would equal 0. So when I'm graphing the first derivative, I can track it right back up here and make it a 0. Okay, and before that hit that 0 slope, what were the slopes of the tangent lines that were before that? Well, if I drew all the tangent lines here, they would be negatively sloped lines. So that means that it would be below the x-axis. Okay, so when we go from the original to the first derivative, we're looking at the placement of the graph being above or below the x-axis, being positive or negative. So if I looked at the curve after the minimum point, all of those tangent lines would have positive slopes. So that means my graph would be in the positive. So this would be the graph of my first derivative. Okay, now I need to make the second derivative. So kind of lose focus of that black one right there and just focus real quick on the red one. So what do we got going on? Well, the entire time, this thing doesn't have a maximum or a minimum. So what that's telling me is the derivative of this red, which is the derivative, the second derivative, but the derivative of this red line doesn't have any x-intercepts because it never actually has a slope that's 0. Its slope is always positive. So I can put a horizontal line up here indicating that this is the second derivative, and it's always positive. And notice this doesn't have any numbers on it. And the reason it doesn't have any numbers on it is because we really just want to talk about the concept as to what's going on with the shape of the graph. It's really not that crucial. The only thing we do pay attention to is that, like, where the minimum was, the x value lines up, but we don't have any y values to worry about here. So that's why I could have placed this horizontal line anywhere in the positive y area. Okay, part B is actually telling us now that what we should do is go back and instead of treating the black line as the original graph, let's treat the black line as the first derivative. So what if this is the first derivative? Well, the easy thing to do first would be now to look at the derivative of that, okay? So if that was the derivative, then let's look at the derivative of that graph. Again, the minimum would say a slope of 0, so we would put it here, okay? And before that, it has a negatively sloped tangent line, so it's below the x-axis, and after it has positively sloped tangent lines, so it would be above the x-axis. But this now would be the second derivative, because it's the derivative of what was there. Okay, now if I want to go in the reverse and come up with the original, I have to think about what would have made this the derivative graph. Okay, so in order for the derivative to be at 0, that means that this was either, this spot right here was either a maximum or a minimum. And the way we tell whether it was a maximum or minimum is what happens before and after it. So before it, it was above the x-axis, so that means before that it was positive, and after it was negative. Okay, so a positive to a negative means that that should be a maximum point. So let's put it up here at a maximum point. This one over here at 0 went from a negative, or below the x-axis, to a positive. So negative to positive, a negatively sloped line to a positively sloped line, means that it would be a minimum. Okay, and for the second derivative, okay, the second derivative being 0 tells me that that's a point of inflection. So somewhere on this x equals 2 line is my point of inflection. So this looks like my point of inflection would come down. Doesn't have to intersect that spot right there at 0. It's just that it has to be a point of inflection on that vertical plane. All right, so this would be my original graph. And do a real quick check and tell yourself, okay, so this maximum and minimum, this curve here, yep, that's cubic, to a quadratic, to a linear. And that's the order it's going to go in. Okay, if we had a quartic, the derivative of that would be a cubic, whose derivative would be a quadratic, whose derivative would be linear, and the derivative of that would be horizontal, okay, and the derivative of that would be 0, or the x-axis. And that's as far as we can take it. We can't take the derivative of 0, okay? So that's kind of what you're looking for. So if my original graph started here at quadratic, then my first derivative was linear, and my second derivative was horizontal. I lost my pointer for some reason. And my second derivative was horizontal. If my first derivative was quadratic, then the original was cubic, and the second derivative was linear. Okay? So it might be helpful to have this written off to the side to know what kind of graphs you're expecting. So we're going to do a couple more of these. So here we have a graph. It looks like this is a cubic, and it is the original function. And what we're actually looking for is the first and the second derivative. Okay? So this is cubic. That's f. So I'm expecting quadratic, right, for the first derivative, and I'm expecting linear for the second derivative. Okay? All right, so again, here we go. The original has a maximum here, which tells me that the first derivative has a 0 there. It has a, how does it keep doing that? It has a minimum right here, which means, again, that that's going to be a 0 for us on the first derivative. Okay? Before this 0, it was a positively sloped line, which means we were above. After this 0, it's a negatively sloped line, which means we're below. Okay? Right here, halfway in between the minimum and the maximum, is a point of inflection, and that's actually where our minimum or maximum on our derivative is going to fall. Okay? And it's still below the x-axis, so it's still a negatively sloped, negative, 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 negative. It doesn't turn positive, or it doesn't go into the positive range until we get past that minimum. So there's your first derivative. And in fact, yep, we were expecting quadratic. We were expecting a parabola. We're focusing on the parabola. We have a minimum here, which means then that'll be a x-intercept for us for the second derivative. It was a negatively sloped curve before that, so that means we're below the x-axis. And it's a positively sloped curve after that, so it's above the x-axis. So right here is my second derivative. Okay? All right, again, pause if you need to. I'm going on to the next graph. So here we're starting with a parabola. All right, so that's a parabola. But this parabola is actually being told to us is the second derivative. That's the second derivative. So we're going to back it up to. So cubic is what we're looking for, the first derivative. And quartic is going to be our original function. All right, so we've got to build backwards here. Okay, so right here, we have on a derivative, we have a 0, which means the one before it, the one level before it, it was a maximum or a minimum. And we went from a below, from negative to positive. And negative to positive means that it was a minimum. So down here is going to be a minimum. For this one here, it's saying that it was a 0, but it's going from above to below. So it's going from positive to negative, which tells us it was a maximum. Okay, and with this one being a maximum, that means my point of inflection would fall right about there. And we are expecting cubic, so expect a cubic shape going on here. So go through the point of inflection, and then we're looking at concave down. Okay, so for my next one, focusing on the red, okay, I have a, actually, what I need to do is bring this up here further, right? And I need to bring this down here further. Okay, so I have a 0 right here that went from positive to negative. Positive to negative means this would be a maximum point. I have a 0 here that went from negative to positive, which would mean it would be a minimum point. And I have a 0 here that went from positive to negative, so that means it would be a maximum point. And anytime that the second derivative from this is equal to 0, it would be a point of inflection, so that means this is a point of inflection. And that means this is a 0, so this is a point of inflection. So you can see this is a shape of the chordic function we were expecting. Okay? Again, you can pause it, rewind, do what you need to do. I'm going to go on to the next graph before I run out of time. All right, so what's given to us is the first derivative. So the first derivative you can see is cubic. That's the first derivative, and we're going to find the original and the second derivative. So if that's cubic, the original is going to be quartic, and the second derivative is going to be a quadratic. I like to do derivatives first, so I'm going to go for that quadratic one. Okay, so this minimum here becomes a 0 of the derivative of it. Its maximum becomes a 0. And we know that between these two, let's see how I can put this. Between these two, it is actually positive slopes, so it should be above the x-axis, and on this side it's negative slopes, and on this side it's negative slopes, so those should be below the x-axis. I think I put that wrong on my paper. So it should be above the x-axis here, and below the x-axis there. So there's my second derivative. All right, now I'm going back to the original, which is going to be quartic. Okay? So if it was a 0, that's a minimum or a maximum. Then it went from positive to negative, so that means it's a maximum. And if it's a 0, it's a minimum or maximum. It went from negative to positive, which means it's a minimum. And another 0 that went from positive to negative means it's a maximum. So here is my original graph then. And I can go through and talk about how it's easy to follow those points. I can go through and say, okay, well, the second derivative was 0, so that's my point of inflection. Second derivative was 0, so that's my point of inflection. Okay, so sometimes there's overlapping information that we're being given that we don't really need to use. Okay.